Welcome everybody to the October's edition of DevSecOps Live. DevSecOps Live is a monthly event, usually happens on the last Thursday of the month. Brought to you by Practical DevSecOps. We bring industry experts who are working in the field of security and then to share their experience with our attendees here. The session is being recorded, so if you've missed the session today, it will be available at our YouTube channel, youtube.com/practical DevSecOps. And if you want to stay up to date on our upcoming events, follow us on our LinkedIn page. We have Aditya Vasekar today, and he's been modest on putting any of the designations there. He's a product security engineer at Microsoft, performing a lot of work on artificial intelligence, blockchain, and today he's going to talk about the shortcomings of the AI technology, how the current AI technologies that are available for the public, and how do those technologies consume our data, how do those technologies consume and share and build their own models, train their own models based on our own data, and then how by using blockchain, you can sort of put a leash on those AI technologies. So that's today's talk. If you have questions, use the chat or use the Q&A section any way you please. For now, I'll give it over to Aditya Vasekar to enlighten us about putting a leash on artificial intelligence. Over to you, Aditya.
Okay, thanks, Maran, for a short summary, for the short introduction. Okay, and thanks for giving me an opportunity to speak on this platform. Again, let's get started. Okay, so the today's topic is is kind of revolving around the AI. There are like a lot of platforms, algorithms available. A lot of people talking about playing with a lot of different stuff nowadays. Okay. So yeah, let's sail on the boat of the AI. So here, nowadays, people have started, anticipating actually the power of the algorithms which are available in the market. So there are like a lot of organizations, they have started. Previously, it was about only about the development of the AI. Now, everything is now revolving about how you're applying it to your day-to-day basis. How you're using it, implementing, and getting outputs by using it. Okay. So now, why it is important, the topic, why it is important today, because today's AI platforms are like, built with the algorithms which are like an opaque box. We don't know what is going in and, whatever the results are coming out, we don't know how those are like, processed and coming out. Okay, the reason behind is like, whatever the algorithms written, the question is still there, are they really, adhering to certain kind of guidelines, platform, like, a framework or, any set of secure baseline or not. So how, so today we are going to talk about the challenge which is there and how that can be addressed. So that's the second point. How? So it is about tethering these algorithms using the blockchain technology. So we all we know how the blockchain works. It is like, a distributed set of nodes, and that can be used to tether all these components which are scattered or unknown, or they can be tampered. God knows what else is happening there. Okay, so now let's get started with the dissecting the truth. So the point is, should we really trust whatever is provided by the AI platforms today? So whenever the development of any kind of AI platform is started, it really starts with the purpose. It should really start with the purpose. For what purpose it is being designed, and it's absolutely fine if the purpose is kind of changed later on, because on the day-to-day basis there are new challenges and those can be accommodated during the design phase. Then second is the intended domain of the application. A lot of time, we see the whatever the intended domain of the application, that might change, that might drift along, whatever the requirements are presented or challenges are presented. The training data, the testing data. So about the training data, whatever the training data which is being used to train these algorithms whenever they are in the testing phase, those are like, do we really have any kind of secure guidelines or baselines? Based on that, the training data is fed to these algorithms. The testing data, again, there is no, there are no checks, or there are no set of benchmarks being used for the testing data which is being used to train these algorithms. Then the models and algorithms themselves. So are these models and algorithms are really working as per the design or not? So there is no real set of benchmark or kind of a framework in order to identify these things. Okay, so the inputs and outputs. So it really talks about like what we discussed already. What input is given and what are the outputs? Are we really can we really control it? Because later on we are going to talk about the risk and liability for whatever the outputs are coming from these algorithms. Then there are the performance metrics. So do we really have any kind of guidelines or again the frameworks to measure the performance of these algorithms? Because there should be some, like, whenever we design any kind of solution, the expectations are there. Do we really know what we are expecting? Do we really can we measure that? Is that tangible? Can we measure that using some kind of matrix or not? Then there is a bias. Bias outputs, we already know there are like lot of cases, court liabilities, or a lot of organizations are already facing in different countries due to the biased output whatever the platforms are giving. And last one is about the explanation. Really, how this can be explained exactly. Because whenever there is an incident, there is no explanation, exact explanation, apart from we look at the logs. Okay, this was the incident. This is what happened. But actually, when you try to pinpoint, okay, what exactly when you the forensics guy actually they can relate to how the incidents are like measured or tracked or are documented. Then the real cause is not that cannot be documented in these kind of cases. Okay, so now let's look at the famous the algorithms what we have today. So the first one, very unique one, the opaque box algorithm, like the Markov chain. This is a very very simplest algorithm for usually used for the prediction. You can see there is a square box, 0.9 is to 0.1, 0.5 is to 0.5. So this is like the prediction model. Like this works like, if there is a 90% chance of having a rainy day today, there might be a 10% chance of a sunny day tomorrow. Okay, it's like, again, if it's a 50% chance of rainy day today, then it will be like a 50% chance of being a sunny day tomorrow. That's how the mix and matches of these the prediction work. The outputs are again calculated and presented. So that's a Markov chain, very very simplistic version of the algorithm for the prediction algorithm. Then there are genetic algorithms which actually mimic the principle of natural evolution. So as time goes on, these kind of algorithms, they kind of turn up to be very powerful algorithms. So the reason behind this is like whatever the inherited data which is being used to train these algorithms, they absorb it. The predictions become more and more stronger. Okay, That's how these kind of algorithms work. Then supervised and unsupervised machine learning. We know these. There are like very good examples of supervised and unsupervised is like a driverless car. You know these kind of examples can be tied up to this. Then there is a generative AI. So we know DALL-E. Now there are like the recent integrations of DALL-E with the Chat GPT that is happening in the new version. There are other generative AI algorithms in the market. For image predictions, image creations, all those things. Then there is reinforcement learning, deep learning. These are again, there are like a lot of applications. Again, very strong and very powerful algorithms. These are like, where the training data is cannot be defined. These algorithms learn as you go. Driverless cars, these are like very good examples nowadays. A lot of algorithms are being used in that case. Then last one is like program synthesis. You must have came across, Codex, Copilot. So now, the recent announcement of the Copilot is like, it is being integrated with a lot of Microsoft platforms, Teams, Office, and all those things. So it's so these platforms are like, as per the instruction, they can generate the code, provide you different algorithms. Okay, so these are like, some famous different types of algorithms, platforms available. So now let's look at the current attacks and, the failures what we have nowadays. So there is for the first one is about the data drift. So the data drift is about, earlier we talked about the intended purpose of any application or any platform, and as the time passes, the model drift, the data drift happens because initially a very classic example, like initially we started training our algorithm for some weather predictions, okay, but later on, later on it was like used for some other purposes, like some market predictions, or it happens because people start providing data to the algorithm based on their own set of requirements, as whatever the challenges they face. So that's like a data drift. And that's happening nowadays, with a lot of algorithms. That's a current challenge, I would say. Then there are different types of like adversarial data attacks, poisoning attack, evasion attacks, impersonation. So poisoning attacks is like, they are like specifically very much targeted to the data sets, like the training data sets which are provided to the algorithm. So attackers are able to poison the data, manipulate the data, and then feed it to the algorithm, and the way it tries to learn, and whatever the output which is created, that's completely unexpected, and that can again draw the risk and liabilities further. Evasion attacks, so it is like attackers are like pushing the boundaries of the the labels for whatever the training data which is being provided to the algorithm. It's like a very good example is like attacker might provide all the poodle images of poodle dog to the algorithm. So what the algorithm will do is like it will be able to identify the poodle as a dog, only poodle as a dog. Otherwise, other breeds cannot be they will not be identified as dogs. So that's kind of evasion kind of thing happens. Now the labels are changed, breached. Then there are like impersonation attacks. Those are like mostly related to the biometrics. Whenever they are targeted against our organization, where the algorithm the algorithm is trained for identifying the biometrics of the people for a different purpose, that can be changed. Now coming to the risk and liability, there is still, there are like huge debates still, happening in the market, within the lawyers, like, advocates different within the different countries. The laws are still, unclear, how this can be tracked, or, how the liabilities can be, measured, or how the impact can be calculated, and how the organizations can be penalized, or, that's still debatable, and that's still happening. Okay, now let's talk about the solution. So blockchain as a leash. The reason why we are talking about this is like, we know how blockchain works. Like, the blockchain network it's like, it's like a group of confidence. Each block is like time stamped and linked permanently, and permanently to each other. There are like, whenever the blocks are created, there is a proper hashing created. You cannot tamper any block, or you cannot tamper the data within it. And if any tampering is happening, that is tracked and updated, to the whole network. Now in this case, we were looking at a enterprise level blockchain solution, which can provide, which is like efficient enough to do this, because whenever we look at any kind of blockchain related solution, the performance or efficiency is one of the main challenge, or that's one question. But that's not the case. There are like a lot of enterprise blockchain platforms available nowadays, which are very efficient, very fast. There might be few performance hiccups, but those can be overcome by increasing computational power and all those things. The lot of cloud based platforms are actually providing these solutions nowadays. And like, people are aware how these enterprise based solutions can be utilized for creating secure solutions. I met, recently I came across a very wonderful solution, which was based on the blockchain technology. That's like, kind of IDS IPS kind of solution for medical devices. So that was fast enough and quick enough to identify the network packets on the very real time. That was like, that kind of blew my mind. How the efficiency, how the performance can be actually that cannot be hampered. These kind of solutions are there in the market, and very good solutions are there. So now let's come to the trust and transparency. So why we are talking about the blockchain here. The first one is like, right now we have a situation where we are looking at an opaque box kind of algorithm, right? So whatever we are providing to these algorithms, we don't know what is going to come out. Now this can be changed, like, we have an opaque box, like, the algorithm what we are talking about. Then those, that can be tied up to different blocks. Okay, what is the intent, what is the origin, what are the components? Okay, that's how we can do it using the blockchain. So now so what is like, let's talk about, without a blockchain, what will happen. So this is like a user, on a very a good day, user is like, he was driving a car. Let's look at the example where a user driving a car met an accident with a driverless car. Okay, this is a very unique example where, the driverless car, he gets out of the car, he looks at the car, there is no driver in it. So now he tried to reach out to the police department. Now again, on the call, he is like engaged with the chatbot, which was deployed by the police. Now even that chatbot is not able to understand what the situation was. Then he tries to, the insurance company. So again, from the insurance side, even they deploy their own chatbot. They the user is again not able to explain the situation. The chatbot is not able to explain, understand the options, problem here, and the user, frustrated, drop the call and moves on. So now, now in this case, right now the problem is like there is no, with the time, that as the time passes about this incident, there are no traces. Whenever there is, if someone asks for the a forensics for this particular incident, there might not be enough traces. What happened exactly? Why it happened? So now in this case, there is no. The intent is unknown. The origin is unknown. Again, we cannot say what were the components included in this particular incident. So that's how we try to bind it to particular blocks. So this type of incidents, they can be tied to certain nodes, so that whenever there is forensic evidence, chain of evidence is required for to dissect what exactly happened, then these blocks can be taken right away, directly, and they can be reported. A detailed report can be created. Okay. So now let's see, how this can be established exactly. Okay. So we can talk, we can break it into 4 different controls. So the first control is about pre-establishing identity and workflow for people and systems. So it is like whenever we try to establish a project for any of the AI platform, we need to establish the identity, the workflow, everything that can be mapped to the different nodes in the system. Okay. The second control is about distributing tamper evident verification. Now we'll talk about more in the further slides about this. So it is like you need to use some kind of solution to make it tamper evident. Like whatever the blocks which we are going to create, whatever the data is, whatever it is going to reside in it, so that should be tamper proof. Okay. So the third one is about the governance. Now about the governance, it's like we need to look at how this can be how this can be governed and traced and tied, and look at like, okay, what are the different approval processes or checkpoints what we are going to include in this. Okay. So that's the governance we are going to talk about. The fourth one is about the authenticity through user interactive interface. So this is about the interface where you might have seen, there are like a lot of blockchain related solutions available in the market, but the building an interface to that particular solution is kind of a challenge, a big challenge. Okay. Now in this case, we know how the technology is going to work, but how the challenge is how we are going to project it. Okay. So because whenever there is an end user, like less technical users are involved in this case, when there is no user interface, we can't say, okay, go and log it into your AWS account, you will get different evidences, pull the report. How? That's the question, right? So in that case, the fourth control, building a proper interface, getting an exact output reports, or that's how we can establish the trust. Okay. So that's a control 4. Now let's see the control 1, the pre-establishing identity and workflow for people and systems. So in this case, like when I say establishing identities, predetermining workflow among participants, it is like you can say 3 boxes here. One is AI engineer, there is ML operations, then there is an end user. So AI engineer, this is like one node, one node is tied to it, which actually preps the data, trains the model, submit the trained model. Okay, then it comes to the ML operations. Now they recreate the test model, recreate the data, test the model, then provide feedback to AI engineering again. AI engineer, and then the final step, like deploying the model. Then this system goes to the end user. End user analyzes it, reviews it, gets a feedback, gives a feedback about whatever is happening on the algorithm. So now this is like we have established different identities, the workflow is determined, the checks are there. Okay, that's what we are going to do in the as a part of the governance. This is not, it is not happening like, okay, now AI engineer is like doing analysis, recreating everything, and there is no random things happening here. These are like associate designated roles, and this is what going to happen. So control 2, yeah. So distributing tamper evident verification, like I said, we need to come up with some kind of solutions. Those can be used in the our blockchain solution. So we can use the crypto anchors for the data set, like for doing the model verification. So crypto anchors, these are like set of you can create these crypto anchors to create a tamper evident nodes. So in this case, whenever you create a crypto anchor, these are like hashes or hashes created in a very secure way. Those cannot be tampered. Okay, so governance again, it is like establishing a governance group, then implementing on chain governance. So it was a very good project. I was looking at this project, implementing chain governance. So IBM has came up like very good project. I think they are still, I don't know if they're still working on it, what has happened, but they came up with this solution, like they established a chain of governance, like chain of users who actually kind of created a framework, the whole framework, who actually look at different set of users, and what kind of roles they have, what kind of duties they have, and this is like the chain of events they have. There's like whole big project which is created around this to get a formal version of a framework which can actually legalize, or not legalize, but control the AI related output, AI platform in a way. Then fourth is like about the traceability, about the interface, how this can be built using the blockchain. Okay, so this was the whole thing about the like this is all about the implementation. So now talking about the solution, what kind of what kind of platform is actually used. So we have used like Hyperledger platform so for building this solution. So that's kind of really super fast. I would say we are still looking at the performance. It's still not giving expected results. Still, it was done just as an POC from my end. We are still looking at how this can be worked from the efficiency point of view. The interface is still in a very raw stage that cannot be presented yet. So overall the concept is like these nodes, the platform which is like the Hyperledger stuff, that's still that can be installed. There are like a lot of different connectors available to connect to the database, to connect to the different interface. Nginx connectors are available, different web app containers connectors are available for this. And using those connectors, you can actually project the solutions to the particular interface. So that's kind of possible. So that's it from my side. How this how the blockchain can be utilized for controlling the AI platform, the AI algorithms in a way. So that's overall. So let's see. Let's look at the questions. If anyone has, maybe Maran, if you can.
Definitely.
Yep.
Thank you very much, Aditya. Very, very insightful in terms of the attacks on AI and controls that we can implement. Any questions to the speaker? Please put them or use the Q&A section. Let's see. Okay, if there are none, the webinar is being recorded. If you want to share it with somebody, it will be available at our YouTube channel, like I said before. And if you want to know the upcoming events about DevSecOps Live and the topics that we're going to present in the next couple of months, follow Practical DevSecOps LinkedIn page. For now, I'd like to thank Aditya for being here, accepting our invitation to share some of the research that he's been doing in terms of artificial intelligence algorithms and using blockchain as a leash, right? Thank you very much, Aditya, and thank you very much, everybody, for tuning in today. Hope to see most of you on the next editions of DevSecOps Live as well. Till then, my name is Mario. I'll be a host for DevSecOps Live. I'll see you next month or sooner. Thank you very much. Have a good day.
Thank you.
Thank you, Aditya.